Good morning or good afternoon or good evening. It's Miss Bowie here, and today we're going to talk about transformations. Now, a transformation is just a change in size or shape. So, for example, if I were going to have a triangle, and then maybe I flip it around so then it goes like this, that would be an example of a transformation. You can also move it. It's change in size or shape. Now, a pre-image is what we call our image before the transformation. So that would be the original one. So our pre-image is, think of it like your original. It's before we transform it. And the image is our shape after the transformation. Now, we call it, if you see, so I have triangle ABC, and after I transform it, I call it triangle ABC prime. That's what these little symbols mean, is prime. So if you've ever seen the movie Transformers and they have Optimus Prime in the movie Transformers, it's like Optimus Prime after he transforms, it's the same thing here. After your transformation, you add those little apostrophes and we call it prime. Now, isometry is whenever your shape remains congruent after the transformation. So for example, the one that I had up above. So if I have this and then let's say that I flip it over, if it's congruent, which that's not quite congruent, but if it's congruent, that's called isometry, or we call it an isometric transformation. And sometimes we also say that we have what's called rigid motion. So rigid motion is whenever there's no change in size, meaning that it stays congruent. And non-rigid motion is whenever we have a change in size, whether it gets bigger or smaller. Now, down here, these are our four main transformations. So I can slide, so that's called a translation, is whenever my triangle slides. A reflection is whenever it flips, and I'm saying triangles, but it could be something else. So reflection is whenever it flips. A rotation is whenever it turns, and a dilation is whenever it gets bigger or smaller. So translations, reflections, and rotations, these are all considered rigid motion. And that's because our shape doesn't change size. It's still congruent, it just moves somewhere else along the graph. A dilation gets bigger or smaller, so that's what we call our non-rigid motion. So for dilations, you can either have an enlargement or a reduction, meaning that it either gets bigger for enlargement or reduction is smaller. And the scale factor is that change in size. So for example, if I double everything, that would be a scale factor of 2. If I triple it, that would be a scale factor of 3. And those are enlargements because my scale factor is bigger than 1. But if I halved it, or maybe I did 1/3 of it, or 1/4 of it, those scale factors are less than 1. So change this greater than symbol to a less than symbol. And that makes it smaller. So whenever you have a reduction, it's whenever your scale factor is less than 1. And our scale factor formula is right there. It's just new over old. And we'll talk more about that whenever we get to dilations. So over here, let's just take a look at some transformations. It says determine if they're rigid motion. And remember that rigid motion just means congruent. So I'm going from my pre-image, which is the old one, to the image, which is the new one. Taking a look at this first one, asking yourself, well, is it congruent or not? And it is congruent, which means that yes, it is rigid motion. It's just upside down. Now this one, from the pre-image, from the old to the new, there's zero change, which means of course that's congruent, so that would also be rigid motion. And then taking a look at this next one, right here, so I go from my pre-image old to the image, which is new, so I go from there to there. Well, I notice that it shrinks a little bit. That's a reduction, which means that it's non-rigid motion because it changes sizes. I'm going to give you a minute to look at that last one on your own. And hopefully you got that it was rigid motion. All that it did was just flip over from one side to the other side. That was it. So that's rigid motion. Now, a lot of times for our transformations, they use their own lingo or their own terminology. They're not going to spell out reflection, translation, rotation, dilation. They're going to use these symbols. So if we take a look, a lowercase r right there, if you had to take a guess, do you think that that would be a translation, reflection, rotation, or dilation? Well, it says r over the x-axis, which means a reflection over the x-axis. So that's a reflection or your flip. And if that lowercase r stands for reflection, what do you think the uppercase r is going to be? And it says 90 degrees. That's a hint. That would be a rotation, which means that capital T would be your translation. And our last one would be our dilation. Now, if you remember the reflection, translation, rotation, and dilation part, then you're good to go because it's going to tell you what it wants you to do. So for example, this would be a reflection over the x-axis. This would be a translation, AB, which means that the x part goes with the A, that's left and right, and the B part goes with your Y, which is up or down. The rotation would be a 90-degree rotation, and dilation would be with a scale factor of K. So you just multiply your coordinates. Now, keep these pages in mind as we go to take a look at our first transformation, which is translation. Now, think back, what did translation mean? And if you said slide, you're right. So let's take a look at how we translate, how we slide an image. The vertices of triangle ABC are A is at 1, 4, B is at negative 1, 2, and C is at 3, negative 2. I'm going to go ahead and put those on my graph, but I need to be very, very careful and label them. So A is at 1, 4, put point A there and label it. B is at negative 1, 2, put point B there and label it. C is at 3, negative 2, put point C there and label it. And now I'm going to go ahead and connect them. A lot of transformations is just connecting the dots. And we have some artistic skills there. Okay. It says graph the pre-image, that's my pre-image, and its image after a translation that's 4 units left and 1 unit down. So what that means I'm going to do is I'm going to take all these points, every single one, I'm going to go 4 left and then 1 down. So doing that, I'm about to go 4 left. So if I go 4 left, that'd be 1, 2, 3, 4, and then 1 down. So A prime should be there. Remember that whenever I transform it, I'm going to add in that prime. So I'd call it A prime. B would go 4 left and then 1 down. So that would be B prime right there. And then C prime would go 4 left, 1 down. So C prime should be right there. Now, the triangle should look exactly the same. It should be rigid motion. It should be congruent. All that I've done is just translate it over. All I've done is just slide it over. Okay, now what it says next is to describe the transformation in arrow notation. Now, arrow notation is fairly simple. It starts out with just an ordered pair, x, y. And arrow notation says if we take that general point, well, what did we do to it? So arrow notation says that we went from x, y, arrow, hence the name arrow notation. Well, we went 4 left. So would left go with x or would left go with y? Well, left goes with x, and if I go left, it would be x minus 4 because I'm going left. And if I went 1 unit down, that would be y minus 1 because I went 1 unit down. And that right there is arrow notation. That's it. So it's x comma y, arrow, and then I just state whatever happened. So that was arrow notation. Vector notation is what we just saw a moment ago, just like this. So for vector notation, I'm just going to have something like this. So I'm going to do translation was a capital T. And I'm going to use different brackets. I'm going to do brackets like this. And if I went 4 left and 1 down, then I'm going to do this. -4, -1. That's it. That's vector notation. So I have a capital T because it was a translation. It went 4 left, so that's in the X spot, 1 down, so that's in the Y spot, and then that's it. Now, vector notation can seem a little bit intimidating at first because you've probably never heard of vector notation. It just looks different, but that's it. Vector notation is a little bit easier to write. It's a little bit less writing than arrow notation. You just put a capital T, and then you just put whatever those transformations were in the appropriate spots, and that's it. So let's take a look at this next one. They've already transformed it for us, or they've already translated it for us, so they just moved it over there. It says PQRS is a parallelogram. Use arrow notation and vector notation to write a rule that describes the translation from PQRS. And remember, this is to P prime, Q prime, R prime, S prime. Sometimes people will say PQRS prime. Now, remember that without the prime, that's your old one. And with the primes is your new one. Or we call the old one the pre-image. And the new one is our image. So I'm going from this black one to this blue one, and I know that because I can see those prime markings. So I'm just going to count. How far do I go? So I go 1, 2, 3, 4, 5, 6 to the right and up 2. And it should be that way with all of my points. So now I'm going to count 6 to the right, up 2, and it works. So I know that I'm going 6 right and up 2. So in arrow notation, I'm going to start out with X, comma, Y, arrow. And if I go 6 to the right, that would be 6 added on to X. Up 2 would be 2 added on to Y, and that's it. Now from there for vector notation, remember we start with a capital T. And then we have our pointy brackets like that. And I'm going to do 6 because that one with the X, and 2 because that one with the Y. And I read that saying up 6, right 6, my bad, y'all, sorry, right 6, up 2. And that's it. So taking a look at this one, it already graphed the original. It says the vertices of triangle JKL are at J, -1, 4. K is at -2, -2, and L is at 1, 2. Find the image under, T would be translation, 4, 3. Now 4 is in the X spot, which means that it would go 4, positive 4X would be right 4. What do you think the 3 would be? You said up 3, you're right. So what I'm going to do is I'm going to take each point and I'm going to go right 4, and then I'm going to go up 3. And remember, whenever I'm transforming or I'm translating these, I'm going to be very specific with my notation. So I'm going to start with L, and I'm going to go right 4. So 1, 2, 3, 4. I'm going to go up 3, 1, 2, 3. Put a point right there. I'm going to call that L prime, just like that. So with K, I'm going to do the same thing. I'm just going to count over 1, 2, 3, 4, and then I'm going to go up 3, 1, 2, 3. So K prime should be right there. And same thing with J. I'm going to go right 4, 1, 2, 3, 4, up 3, 1, 2, 3. And there's J prime right there. And if I connect them, it should be congruent to the original. And you can just kind of look at it and tell that it is. And that's how we do a translation. I want y'all to try this next one on your own. Now remember that -2 with the X would mean that it would go left 2. And Y -5, take a guess. That would be down 5. So take a second and see if you can go left 2, down 5 on your own. So if you go left 2, down 5, that first point, Q prime, it doesn't have to be the first, but Q prime should go right there. Now, if I have P, I should go left 2, so 1, 2, down 5, 1, 2, 3, 4, 5. And it helps if you're good with graphing and plotting points whenever you do these. And then R, left 2, down 5. And that's a translation. So remember, a translation is just a slide. It's congruent. So see, it's congruent. You can almost like copy the whole thing, and then I could just go left 2, down 5. Just like that. That's what a translation is. Now, the next one that we're going to take a look at is a reflection, and a reflection is just a flip. So this says describe how to map the shape to its image. So first you have to figure out, what is it flipping over? Is it flipping over a line like this? Is it flipping over a line at an angle, or is it flipping over a vertical line like this? So I can kind of tell it's flipping over a vertical line, But I remember I want to find like the middle of what it flips over. So if know it flips over a line like this, it needs to be in the middle of these two shapes. So if I know it's a vertical line, trying to find the middle, if I kind of move this over, right there is my line of reflection. Now, the problem says describe how to map the shape to its image, and that goes back to what we had up here. We know that it's a flip or a reflection, so I'm going to put R and then just state whatever I'm flipping it over. So for this one, I'm going to say R, lowercase r for reflection. Now, it's a vertical line. Remember that vertical lines like this will always be x equals a number. Whereas horizontal lines like this will always be y equals a number. So I know this is vertical. All you have to do is figure out what's the x number where it crosses, and that's at 1. So it would be reflection. It would be a flip over x equals 1, that vertical line. And that's how I map the shape to its image. That's it. So down here, if I try to cut it, like flip it that way, that wouldn't quite work. It's not quite at an angle. This would be a horizontal line. And if I stop somewhere in the middle, I'm trying to find the middle of the two shapes, it should be right about there. Okay, I know it's in the middle because to that way, That's what I mean when I say it's in the middle. It should reflect and be the exact same on both sides. Now, this is a horizontal line. Horizontal lines are y equals a number. So if it's y equals a number, I'm going to go to the y-axis. I see that it crosses where y is -1. So to map it, I'm going to do a lowercase r. And it flips or reflects over y equals -1. And that's how we map a reflection. That's it. So reflections are probably, I like to say, one of the nicer ones to do. Translations, you have to count so many points. But reflections, we're just going to kind of flip our image over. So if it's over y equals 2, well, remember, go back. Y equals a number is a horizontal line. So if it's where y equals 2, I'm going to put a point where y equals 2. I'm going to draw a horizontal line. And that's your mirror. So the way that it works is that I'm going to flip all of these points over to the other side, and it needs to be equidistant. So if D's 1 up, then I'm going to go to my line of reflection, and D prime should be 1 down. If C is 1 up from my line of reflection, then C prime should be 1 down from my line of reflection. So A is 3 away, 3 up from my line of reflection, so A prime should be 3 down from my line of reflection. And if I kind of fill it in, I can just see B prime should go right there. And there's your rectangle. That's it. So I like reflections because sometimes once you get the start of your shape, you can just kind of fill in the rest of your shape and go from there. So let's take a look. It says the vertices of triangle ABC are A is at 1, 3. I'm going to remember to label. B is at -2, 4. And C is at -1, -1. I'm going to go ahead and connect. And it says graph the image under the rule of our x-axis, which means we're going to reflect it across the x-axis. So think of the x-axis like your mirror of reflection. Now, it doesn't matter which side things are on, they're just going to flip over to the other side. So if A is 3 up from my line of reflection, then A prime should be 3 down from the line of reflection. Remember, I'm thinking of this line as like a mirror. That's what I'm flipping over. So 3 away, 3 away. Now C is 1 down from my line of reflection, so C prime should go 1 up from my line of reflection. It's flipping reflection, flip sides. And if B is 4 up from the line of reflection, then B prime should be 4 down from the line of reflection. And that's it. All I'm doing is taking those points and flipping them over the line of reflection. And let's take a look at our last reflection. If A is at 2, 3, B is at 5, 1, and C is at 4, -1, graph the image under the rule of x equals 1. Now remember that x equals 1 is a vertical line, so it should look like that, where x is 1, which is right there. So this is my mirror right there, a vertical line where x equals 1. So I'm going to give you a minute to see if you can flip these over. Remember to note them as a prime after you flip them, after you transform them. And you can pause if you need more time, but hopefully you're on the right track. If A is 1 to the right, then A prime should be 1 to the left from my mirror of reflections. There's A prime. If B prime is 1, 2, 3, 4, and then I'm going to go to the other side, I'm going to go left 4, right there. There's B prime. And if C is 3 to the right, then C prime should be 3 to the left, right there. And there's my flipped triangle. Notice that I labeled everything with the primes, so it's very clear to tell that this is my pre-image, or my old one, and that this one over here with the primes is my image, or my new one. That's all the transformations that we're going to take a look at today. Tomorrow we'll pick back up to go over rotations and dilations. Good luck with your practice.